In this video, we'll look at a different output command called sprintf. So I'm going to create a new subsection here and call this sprintf. The S stands for string. So S for string. This command saves the text that you create and stores it as a variable to be used later. String to be used later. For example, in graphs or charts. This can be a useful thing. Let's look at an example. So I'm going to copy in an example question here. This asks us, if I throw a ball into the air with an initial velocity of 20 meters per second from an initial height of 2 meters, how high will it go? So we're throwing it straight up into the air. This is a Calc 1 physics question, or not Calc 1 if you're given the formula. Calculus is how you derive the formula. But anyway, remember it's a good idea to solve a problem by hand first to make sure you know how to do it before you try to tell MATLAB what to do. Because MATLAB isn't smart enough to know how to solve it, it just carries out the instructions that you give it. So let's figure out what we need to do, and then we'll plot the height as a function of time, add a text box, this is where the sprintf will come in, that says how high the maximum height is to answer the question. So let's create a solution, and in order to solve this problem, we need a formula for the height as a function of time. So let's use a formula from physics or calculus, depending on what your background is, to find the height of the object. We know that, and then I'll put the formula in the comments here. Height is a function of time. That's negative g over 2 times t squared plus, and then we take the initial velocity times the t and add the initial position. So we're using S for position. Let me just copy over some of these definitions here. So g is the acceleration due to gravity, v naught or v0 is the initial velocity, and s naught or s0 is the initial position. So now that we have some comments and we know what we're doing, we just need to fill in some stuff. The question is in meters, so I'm going to use 9.8 meters per second squared. Remember, it's always a good idea to use the comments to show units for your variables when applicable. Initial velocity. So initial velocity is 20. That was given to us. Initial position was 2. Then the units here are meters. Units are meters per second, 20 meters per second. And now what I need to do, so I'm going to make myself a little note here in my comments, say, okay, now that I've got some stuff laid out, I need to plot height versus time, calculate max height, and add text to plot with max height. Those are the 3 remaining tasks that I have to do. So this to-do with a capital to-do is something that I can search for later when I'm trying to remember where I'm at in the problem. So let's do it one at a time. Let's plot the max height, plot the height versus time. So I'm going to create a bunch of times. I'll say start at 0, count by 0.1, and go all the way to 4. I don't know. I just picked a number. Maybe I needed to go to 10. Maybe I needed to go to 20. I don't know. We can adjust later. So let's start with 4. An array of times. Can adjust later if needed, in case I don't get all the way to the maximum. And calculate the height at each time. And here's where I'm going to create an h variable where I take each t value and do something to it. I definitely don't want to type this out for every individual t. So we're using the vectorization of MATLAB to say, do this for all the t values all at once. Each of them is going to take negative 1 times g and divide by 2. I don't think I need that dot. Probably wouldn't hurt, but let's divide by 2 because g is a scalar, and star t squared. This dot I definitely do need because I want to individually square each of the items in t. Add the initial velocity times t. So dot star t. I don't think the dot's necessary here, but t is an array, so it's a good habit to stay in. And then add to that the initial position. So I could have called these s_0 and v_0. I just happen to call them initial velocity and initial position. Definitely suppress that. I do not want to see a whole bunch of heights. I just want to plot them. So let's plot t versus h, or h versus t. T are my x values, h are my y values. And we'll need to label it and stuff like that. So let's do title. Was this a ball? I think it was a ball. Let's call it height of ball. X label will be time in seconds, and Y label will be height in meters. So I like having the units there. Now I've plotted, let's look at my to-do. Plot height versus time, done. In fact, we could run it right now, run the section and see, there it is. We've plotted it. Great. What's the next step? Calculate the maximum height. So I could just scan down the array of h's until I find the maximum. Let's call it max height, and it will be the maximum of all the h values. Okay, I don't need to see it in the command window, so I'm going to suppress that output. But what I want to do is build a sentence that I then put on the chart, and sprintf is how we're going to build that sentence. So let's do that. Let's create the text for the text box, and then we'll add the text box. So let me add a comment here, find maximum height, and then we'll create the text for the text box by saying sprintf. And I'm going to save this as something. So I'll call it my text equals sprintf. This is the difference from fprintf, by the way. I'm going to take the result of this and save it as a variable that I call my text. Then I can use it later. So sprintf max height is, leave a space, and oh, nope, don't leave a space. Do leave a space, but what I want is say .2. I'll just round to the nearest one, actually, one decimal place. Meters. And let's include a carriage return here, close it, and then max height. So use max height as the variable in this sentence. I don't need to know what it is, I just need to tell MATLAB that's where it's being stored. So it will calculate the maximum height here, and then it will use it here. Let's add another word here, the max height. Maximum height if you like. Now it's too long, but why don't I ... this? Nope, did not work. Can't ... inside of a, inside of a string. Okay, so we can't ... inside of a string. That sounds familiar now that I say that. But I do want to suppress this output. So I'll just scroll back and forth. My text, that's a variable name that I just created, sprintf. We cannot do this with fprintf. All fprintf does is send the text to the command window, and that's not what I want to do with this text. I want it on the graph. So let's create a text box, and we do that by saying text 1. So I'll just put the x coordinate as 1 and the y coordinate as max height plus 1, comma. That's the x and y coordinates, and then the text. And the text I called my text. There we go. Let's run it and see what happens. So at 1, and then max height plus 1, that's where it happens to be. The maximum height is 22.4 meters. Cool. I didn't have to figure that out. MATLAB figured that out. MATLAB put it in the text box for me. So here's an example using sprintf to create text and use it in a different location. See you next time.